Hello, students, and hello to everyone. Welcome back again into our channel. So today we are going to look at vertical projectile motion. Okay, yes, and please don't forget to subscribe. Okay, yes. Vertical projectile motion. Okay, so let's look at vertical projectile motion. What does that mean? Okay, yes. So we have three consecutive words there that makes up the term. Okay, yeah. So vertical, projectile, and motion. Okay, so let's start with vertical. So when we speak about vertical, we speak about y-axis line. Okay, yes, meaning that y-axis line. Okay, yes, and this is horizontal and this is vertical. But now we're going to be looking at vertical. What a projectile? Okay, so a projectile is an object, okay, that is in path, okay, after the force has been applied. Okay, yes, so that object means that it has amount of velocity in it. Okay, yes, and that object is moving vertically. Okay, yes, and our main vertical force that I have introduced you about, it's gravitational force, and the gravitational force is the only force that is acting on that particular object. That's why it's said to be as projectile. Okay, yes. So what is motion? So a motion, it's a path. Okay, yes, it's a movement. So vertical projectile motion, we're going to be looking at objects that are moving vertical in y-axis. Okay, yes, and mostly looking at the presence of gravitational force pushing those objects downwards. Okay, yes. So for example, let's say we have this object here. Let's say we have this object. Okay, guess if I can see. Okay, so that object, we have this object. Okay, and the force has been applied pushing that object upwards, so that object will move. As this object is moving upwards, you know that there is a constant acceleration of gravity. Okay, yes, gravitational acceleration, which is pushing this object downwards, or acting on this object downwards. Okay, yes, okay, until it goes down and fell downwards. Okay, to the ground. Okay, yes. So this basically means that there is a force which is 9,8. So sorry, not a force, gravitational acceleration, which is 9,8 meters per second squared. Okay, yes, acting downwards. Okay, acting downwards, constantly acting downwards on this object, acting downwards. Okay, you can see that when this round object has reached a certain point, its velocity, it decreases and decreases and decreases. As it decreases, it will become 0. So at this maximum point, okay, at this maximum point, this will be the final velocity. So meaning that here the velocity of this object, okay, will be equals to 0. Okay, yes, will be equals to 0, because there's no movement at that point. Okay, yes, and then after, the object will then move downwards, moved by what? By the gravitational acceleration, or by the gravity. Okay, yes, downwards by 9,8 meters per second squared. Okay, yes, moved downwards by the gravitational acceleration, okay, which is 9,8 meters per second squared. Okay, yes, that's how it goes. Yes, so these are just the stuff that you have to understand. Just before, we have some examples and some calculation in vertical projectile motion. Okay, so what is the other thing that you have to know? Okay, so we have initial velocity, right? So we have initial velocity. The initial velocity is the velocity that appears just after the force has been applied to push the object upwards. Okay, yes. So we have the initial velocity. So this is the initial initial velocity. Okay, again, there's something that I want to tell you about initial velocity. So if the object has been dropped, the initial velocity is going to be 0. I repeat, if ever the object is dropped, meaning that there's no force that has been applied for the object to be in motion, this basically means that the initial velocity is 0. Okay, yes. So meaning that the object can be dropped whereby someone who's dropping the object is upper the ground, right? Yes, it's up from the ground. So let's talk about the final velocity. Okay, so the final velocity right now, okay, this is how we represent final velocity. Okay, final velocity. What I can tell you about final velocity is that when the object is at its maximum point of path, okay, or I can say that when the object is at its maximum point, okay, the projectile, it's at its maximum point, this basically means that the final velocity is equals to 0. Okay, that's how it goes. And we have the acceleration, the gravitational acceleration. I can just say G or A. Let me just say A. This is the gravitational acceleration, guys. So the gravitational acceleration, this is the gravitational acceleration, right? This is the gravitational acceleration. Okay, so the gravitational acceleration is equals to what? You know, that is equals to 9,8 meters per second squared. Okay, this is the acceleration. Okay, so look, we have to consider the motion on being negative or positive. You have to choose. Okay, but my advice is to, when the object is being, imagine when the object is being projected upwards. Okay, yes, this basically means that the gravitational force is going to oppose the motion, trying to bring back the object into the earth surface or into the ground by applying that 9,8 meters per second squared, meaning that 9,8 meters per second squared is opposing the motion, and therefore I can say we can use that 9,8 meters per second squared as negative. Okay, yes, so that's how it goes. Okay, that's my advice. So we have to regard whether the motion is negative or positive, but don't worry guys, we're going to discuss that. Okay, let's move to change in time. Okay, let's move to change in time. So this is how we represent change in time. So these are the aspects, or these are variables that we are going to speak about. All of them: initial velocity, final velocity, acceleration, change in time, change in y, okay, which is change in displacement. Okay, yes, so change in time, this is change in time. Okay, and its units are seconds. Okay, yes, and okay, so that's how change in time, you know that. Okay, so our object when projected from this certain distance from this point to point B, from point A to point B, for example, it's how long it's going to take to point B. So let's say maybe 4 seconds or 3 seconds or 1 second, whatever the case may be. So this is why we're going to be speaking about change in time, and it's recorded, or its units are seconds. Okay, so we also have change in displacement. Okay, yes, which is change in displacement. Okay, yeah, and this is why we're going to speak about change in y. Okay, we have the same we have the same formula as change in y and change in x, but now since we're speaking about vertical projectile motion, we're going to speak about change in y. Okay, and we apply change in x when speaking about horizontal. Okay, yes, but now we're speaking about vertical in this topic. Okay, so this is, you can say this is change in displacement. Okay, change in in displacement. Okay, as this is changed, this is recorded in meters. Okay, yes, this is recorded in meters. Final velocity, meters per second, so sorry, meters per second, and as well as this one, meters per second, initial velocity. Okay, that's how it goes, guys. Yeah, so we have formulas or the equations to calculate or to work under vertical projectile motion. The very first one, let me introduce you to the very first one. It's, please guys, don't forget these formulas that I'm going to give you, but anyways, they are going to be given into your question papers, and then it's not really that much to know them, but please know when it comes to substituting. And when it comes to substituting, you have to look for the necessary variables. Okay, they must be there. Okay, if you ever maybe want to calculate the initial velocity, meaning that you have to use a formula that has the presence of initial velocity. Okay, so the very first one is, okay, let me write them here. So we have Vf is equals to Vi plus acceleration change in time, right? Yes, this is the very first one. The second one, we have Vf squared is equals to Vi squared. Hope everyone can see. Okay, Vi squared plus 2 multiplied by acceleration change in y, right? Okay, the third one is we have change in y. Okay, change in y, or you can say change in x, but now again, guys, we're looking at vertical y. Okay, change in y is equals to Vi, okay, change in time plus half acceleration change in time squared. Okay, this is the second one, and we have change in y, which is going to be the last one. Change in y is equals to Vi plus Vf over 2. Okay, change in time. All right, that's how it goes, guys. Change in time. These are all equations that we're going to be using in calculating examples or scenarios that are being given. Okay, yes. Okay, so I just want to give you an example so that you can work on the example, guys. Okay, yes, just give me a few seconds. Okay, so there we go to our example. It is given that an object is projected vertical upwards. 4 seconds later, it caught at the same height, point of release, on its way downwards. Okay, determine how long it takes the ball to pass a height of 8 meters in the upward direction. Okay, so in each and every time, guys, we check, okay, on these diagrams. We have to at least draw or make some sort of the diagram in showing the projectile. Okay, yes. Okay, so the movement of the motion of the projectile. So meaning that an object is projected vertical upwards. So this is the object. Okay, projected vertically upwards. Is it called the same height? Okay, so it comes back. Okay, called the same height when coming back. Okay, called the same height, point of release on its way downwards. Okay, this is the same height. Okay, same height. Okay, yes. So so we have to determine how long it takes the ball to pass a height of 8 meters in. Okay, so meaning that okay, look, so this is the same distance from this point into this point. Okay, same distance, the final velocity is 0 here, and from here to this point, same distance as from this point to this point. Clear, right? So as well as time taken from this point of the projectile into this point is the same from this point and from this point, but the whole time taken for this object to move until it reaches the same height, it was 4 seconds, meaning that if ever it is 4 seconds, meaning that we have 2 seconds this side and 2 seconds this way. Okay, yes, so we have 2 seconds this side and we have 2 seconds this side. Okay, yeah. Okay, so yeah, so we have to determine how long it takes the ball to pass a height of 8 meters. Okay, so look, we have time. Okay, that we have to first calculate what? We have to first calculate determine how long it takes the ball to pass a height of 8 meters. Okay, we have to first calculate the initial velocity. Okay, yes, we have to first give the initial velocity so that we can determine how long it takes for 8 meters. Okay, meaning that 8 meters is somewhere somehow in these points around here. Okay, yeah, so let's first calculate the initial velocity. Let's first look for the initial velocity because it's not given, meaning that here we have the final velocity, which is final velocity here, which is equals to 0. What's the initial velocity? The initial velocity, we don't know. We have time. Okay, yes, but we also don't have a distance from this point to that point. But the whole point is to calculate how long it took the ball to reach the 8 meters upwards, okay, to this direction. Okay, so let's go and calculate for red, guys. Let's move this way. So sorry. Let's move this way. Okay, hope everyone can see. Yes, indeed, everyone can see. Okay, so look, let's first do this. Okay, so the initial velocity is not given. The final velocity is equal to 0. Okay, so the let's say change in time is equal to 2 seconds, okay, to that point, okay, to that maximum point whereby the final velocity is 0. What's the acceleration? Acceleration, no, that it was opposing the motion, negative 9,8 meters per second. Okay, say meters per second squared. Change in y is equal to what? We don't know. Okay, we don't know. And what we are specifically looking for, we're looking for initial velocity. Okay, yes. So which equation of motion that we're going to use? It's clear that we're looking for this. Okay, so we don't care for now for this. Okay, yes, so we have this, we have this, we have this. So let's look for the equation of motion that has 1, 2, 3, 4. So this means that will be this equation of motion, which is initial so final velocity will be equals to initial velocity plus acceleration change in time. Okay, yes, so what's our final velocity is equal to 0. What's initial velocity? We don't know, we're looking for plus. Okay, what's the acceleration? It's negative 9,8. What's change in time? Change in time is 2 seconds. Okay, yes, 2 0 will be equal to vi, so this is going to be minus, right? Yes, our answer will be minus. Press on the calculators. Press on the calculators, guys. So negative 9,8 multiplied by 2 is equals to negative 19,6. So we have 19,6. Okay, negative 9,6. So vi is going to be negative to this side is equals to negative 19,6. So this is our vi, and therefore this basically means that our vi will be divided by negative 1 divided by negative 1, 19,6 meters per second. Okay, that's our initial velocity. Okay, so these are marks, guys. Okay, these are marks for calculating the initial velocity. Okay, the very first thing that you have to calculate. Okay, so Now we have the initial velocity, because we can't determine delta y, meaning that the height of 8 meters. Okay, yes, meaning that how long it took for the for the ball or for the object to reach the height of 8 meters. We have to first have the initial velocity. Right now, let's look. Okay, let's go to calculating. Okay, we have the initial velocity right now. So for the initial velocity is equals to 19,6 meters per second. What's final velocity? Final velocity, we don't have it, and I think we don't care about it. Let's say we don't know at that 8 meters. What's going to be change in time? We don't know, right? Yes, change in time there, they said. Yeah, we don't know change in time. What's our acceleration? Also, it's negative 9,8. Okay. What's our delta y is equals to 8 meters, right? Yes, that's how it goes. So in this case, meaning that we're going to look for the formula that has this. Okay, as this as this. Okay, yes. So meaning that we're looking for change in time. Okay, we're looking for change in time. So as we're looking for change in time, we don't care about you. Okay, final velocity. Okay, here. So which formula are we going to use? We're going to use this formula. Okay, change in y is equals to initial velocity change in time plus half acceleration change in time squared. Okay, yeah. So what's our change in y is 8 is equals to, what's our initial velocity? Our initial velocity is equals to 19,6. So sorry guys if you ever can hear the background sound, so sorry about that. 19,6 change in time. What's change in time? Change in time plus half. What's acceleration? Acceleration is negative 9,8. Okay. Change in time squared. We're looking for time, right? The time taken for the ball to reach 8 meters. Okay, when going upwards. So okay, let's multiply. So have 19,6 change in time. So what's half negative 9,8? Press the calculator. Half negative 9,8. That's negative 4,9 minus 4,9 change in time squared. Okay, so as we're looking for time, meaning that we're going to solve for time, for t. Okay, yeah. So let's take all of these to that side of 8, meaning that to the left hand side of over the equal sign. So we're going to have 4,9 t squared minus 19,6 t plus 8 is equals to 0. Let's solve for the problem right now, meaning that we are going to use what? We are going to use a quadratic formula. Okay, yes, which is negative b, it's plus minus, okay, square root b squared minus 4ac, okay, over 2 multiplied by a. Okay, yes. So this will be equals to our t. Let's substitute. So let's substitute right now. Let me just put this one upwards. Okay. Okay, so negative b, what's our b? It's negative 19 comma 6. Okay, plus minus, what's p squared? Negative 19,6 squared minus 4. What's our a? 4,9, and that's our c. It's 8. Okay, over 2 multiplied by a, which is 4,9. Okay, yeah, let's punch that into our calculators. Negative 19,6 square root. Okay, so let's first say plus. Okay, plus square root negative 19,6 squared 4,988 over 2 4,9. Okay, something. Okay, let's check 19,6 squared, set minus there, negative. Okay, so answer is what t will be equals to 3,54, or our t will be equals to shift and say remove positive and say negative, it will be equal to 0,46 seconds. Okay, seconds, 0,46 seconds. Those are answers. Okay, yes, so that's how it goes. That's how it goes. Okay, so yeah, that's how it goes, guys. So I didn't tell you about the free fall. Okay, yes, but I just mentioned some of the aspects when we're experiencing free fall. Okay, so free fall is by an object. Okay, let me just move this one a bit. So a free fall, when you speak about free fall. Okay, so this is free fall. For example, let's say this is the building and I am standing there with the ball. Okay, and I'm going to drop that ball, meaning that I'm going to remove my hands from that ball, and that ball is suddenly going to be accelerated downwards by the force of gravity. Okay, 9,8 by the gravitational acceleration, meaning that it's going to move downwards. So this is called free fall. Okay, so a free fall is whereby an object is accelerating downwards or moving downwards with the presence of gravitational force. Okay, whereby or I can say that this whereby the object is experiencing the only force, which is the gravitational force. That's how it goes. That's the free fall. Straightforward, guys. Yes, so free fall, these are the objects that I've dropped and so on. Okay, yeah. So that's how you go. That's our first example. So let's climb to our second example of the day. And by the way, 0,46 seconds makes sense, okay, because it's less than the 2 seconds. Okay, so meaning that at 8 meters, meaning that the ball has traveled for how long? 0,46 seconds. Okay, that's how it goes. Makes sense. And so we have a scenario here that says a cricket ball is projected upwards from the bottom of a building from point A at a velocity of 20 meters per second. It reaches a maximum height above the building and returns to point B as shown in the diagram below. A man standing on a balcony of the building at a point B catches the ball 1,66 seconds after it has reached the maximum height. Ignore the effects of air resistance. So the very first question says define the term free fall. Okay, yeah, let's define the term free fall. Sorry, let's move downwards. Okay, so 5.1, define the term free fall. So you know that free fall. Okay, so I told you guys, straightforward. Okay, yes, so this is by free fall is the movement of gravitational force, movement of the object with only the presence of gravitational force. Okay, yes, so we can just say free fall is when there is only gravitational force. It's when there is only gravitational force. So this is gravitational force, guys. Gravitational force acting on the object, okay, on an object. So that's free fall, okay, that's free fall. Those are just free marks, guys, straightforward. Before is when there's only gravitational force acting on the object, okay, or on an object. Okay, so let's go to answering 5.2. So these are answers. Okay, so sorry for not writing answers. So these are answers. Okay, so 5.2 says calculate the time it took the cricket ball to reach its maximum height. Okay, so calculating the time for this cricket ball that is being projected upwards. Here it's in the track, it's 20 meters per second. So sorry, just give me a few seconds. Okay, fix that. Okay, so that's it, guys. Okay, yeah, so we have to calculate the time it took for this ball A to reach the maximum point. You know that this ball A was projected upwards. This is A, okay, this A was projected upwards by what? By 20 meters per second, okay, upwards, and this is point B, okay. So this is point A, this is point B, and it passed point B and returned back to be catched at point B, okay. So the question says we must calculate what? Calculate the time from A to maximum, okay. This is maximum point, okay. Yes, maximum point, or let's say it's C, whatever case it starts, just say maximum point, not to confuse you relating to the question. So that's maximum. So we have to calculate the time from A to maximum point, okay. Yes, you know that okay, when calculating regarding calculations, okay, so regarding calculations, you know that, let's say this is initial velocity. Initial velocity is so sorry guys, again, if ever can hear something that is disturbing from the background, which is noise, sorry about that. Okay, so the initial velocity is 20 meters per second. The final velocity will be 0. You know that from this point to that point, so initial velocity and the final velocity is 0 at maximum point. You know that the object is not moving there, okay, it's starting to move downwards, okay, in that the initial velocity is equals to the final velocity, that makes 0, which is accelerations also equals to 0, okay. Yeah, so change in time. What's change in time? From that point to that point, the change in time there is, we have to calculate change in time. We don't know. We have to calculate. It's necessary. Acceleration, it's negative 9,8 meters per second squared. Change in y is equal to what? What's change in y there? We don't know, okay, and it's not that important. But important unknown value or unknown variable is change in time. So this one's not much important. Okay, so let's look for the formula that is this, as this, all these four variables. Okay, so answering 5 point. Okay, let's just say like this. Answering 5.2.1, which is 5.2, right? Yeah. Hope everyone can see. So we're going to use the straightforward formula, which is VF is equals to VI plus A change in time, right? Yeah. So in this case we have to say this is equals to 0. Find this is 0, 20 plus negative 9,8. Change in time. What's change in time? We don't know. We're looking for. Okay, looking for change in time. So 0 will be equals to 20 minus 9,8 change in time. So we put 20 that side, or yeah, let's just say 20 is equals to negative 9,8 change in time over negative 9,8 over negative 9,8. This cancels this, negative is negative, so therefore our change in time will be equals to negative 20 divided by negative 9,8. Negative 20 divided by negative 9,8, 2,04 seconds. Okay, 2,04 seconds. So meaning that from A to the maximum point, okay, to the maximum point, meaning that of the building, okay, the ball moved to the maximum point and down back to B to be catched by this man. So meaning that when it reached the maximum point, the time it took, it was 2,04 seconds. Okay, yes. So we calculated the time it took the cricket ball to reach its maximum height, which is 2,04 seconds. Okay, guys, that's how it goes. So 5.2.2 says calculate the height of the balcony above the ground. Okay, right now we have to calculate the height of the balcony, meaning that the height from this point A to the maximum point. Okay, the height of the balcony. Okay, I have to calculate the height of the balcony. Oh no, it's not to this point. Okay, yes, so we have to calculate the height of from this point A to point B. Okay, yes, the height of the balcony. So in order for us to calculate the height of a balcony, we have to first calculate the height of the whole building. Okay, yes, that's very straightforward. The whole building. Okay, yes, because the balcony is in the building. So meaning that after calculating the height of the building, the whole height, we have to calculate again the height from the top of the building to the balcony to point B. So after having these answers, we have to take this answer and subtract. Okay, yes, this we have to subtract this answer of the balcony, meaning that from the maximum to the point B, which is the balcony, and subtract it from this height of the building from point A to the maximum point. Okay, yes. So okay, so in that case, hope everyone can see. In that case, do we have let's just say like this, initial velocity is equals to what? Okay, so initial velocity is 20, the final velocity is equals to, we are going to first calculate the change in y of from point A to the maximum. Okay, to M, let me say to M. M stands for maximum, guys. Let me just say M stands for maximum. Okay, yes. So we're going to first calculate this change in y of A to M. Okay, so final velocity 0 there to the maximum point. Change in time is equal to 2,04. Acceleration is equal to negative 9,8. Change in y we're looking for. Okay, very necessary. So we have all the variables but except the one that you're looking for. Straightforward. So which formula are we going to use? We're going to use the formula that says let me look the formula. The formula is very straightforward, so it's going to be change in y, okay, is equal to vi change in time plus half acceleration change in time squared. Okay, so this will be equals to, you know, it's 20 initial velocity was change in time. Change in time is 2,004 plus half negative 9,8. What's change in time squared? It's 2,04 squared. Okay, yes. So punch that into your calculator and let's see, guys, what do you receive? Okay, let's punch 2,04 plus half negative 9,8 2,04 squared. That gives us 20,41 meters. Okay, so this is the height of the building, of the whole building, meaning that from point A to the maximum point. Okay, yes. So again, we have to look for change in y of from the maximum point to point B. Okay, from maximum point to point B. Okay, yeah. So we are going to use the very same formula. Okay, so in this case, yes, we do have, yes, all the variables. Okay, so the initial velocity is equals to 0 because it was from the maximum point. Okay, going down, you know, the initial velocity was 0. It's like it was dropped, okay, when it was at maximum value. So the initial velocity is equal to 0. The final velocity will be equals to it's unknown, right? We don't know. Change in time, and we don't care. Okay, change in time is equal to that was 1,66, right, seconds. Okay, yes, when it moved back, yeah, 1,66 seconds. I'm so sorry, guys, didn't see that. You can see 1,66 seconds. Yeah, so acceleration negative 9,8. Change in y we're looking for, so we don't care about you, so we're going to look for these. Okay, yes, so I'm going to use the very simple, straightforward. So change in y will be equals to initial velocity change in time plus half acceleration change in time squared. This would be equals to, what's the initial velocity? 0. What's the time? The time is 1,66 seconds plus 1/2 negative 9,8. What's change in time squared? 1,66. Let's patch that into our calculators, guys. Wasting no time. So 0, 1,66 plus half negative 9,8, 1,66 squared. That's equals to minus 13,50. Okay, which means this meters negative 13,5. Okay, yes. So this is the height from the maximum point to the balcony B. Okay, from the maximum point to the balcony B. This is the, so meaning that from this point to that point you have 20,41 meters, and from this point to this point, from this point to this point, we have 13,50. Okay, so we're going to, in order for us to get, because the question was saying let's calculate the distance from this point into this point. That was the original question. Okay, yes, from this point to that point, as I showed here. Yes, from A to B, to the balcony. So in order for us to get this, we have to take this and subtract this. Okay, yes, we have to take 20,41 and minus by 13,50. So our change in y will be equal to hope everyone can see. Our change in y will be equal to 20,41 minus 13,50, and this will be equal to expression calculators. 20 comma 41 minus 13 comma 50 equals to 6,91. 6,91. So this is our answer, and therefore change in y of point A to B will be equals to this 6,91 meters. So sorry for forgetting the units. Never forget the units, guys. That's how it goes. That's the end of our lesson for the day on vertical projectile motions. I hope you've learned so well, guys. If you ever have any kind of questions, you can comment, you can request other examples and so on. And I'd like to motivate you and to advise you to go and look into more questions and try to practice end and end. Okay, yes. So I'm going to see you in the next time. Okay, yes. Cheers. Don't forget to subscribe. Sure.